living above a valley that still moves. The valley looks calm from a distance. Green slopes, scattered stone, a river tracing an unbroken curve below. But beneath that beauty, the land is never finished. It slides, settles, exhales. And above this slow motion, a hotel was built in a place where the ground never truly stops adjusting. At first, the location seemed ideal. Sheltered from wind, rich with water, framed by mountains that promised permanence. Yet, local records told a quieter story. Over decades, buildings had cracked, roads had warped, trees leaned at unfamiliar angles. The valley floor was drifting, not dramatically, but constantly. To understand why this hotel matters today, we have to return to the moment the land revealed its truth. During early surveys, laser measurements taken weeks apart refused to align. Reference points moved by centimeters. Slopes shifted just enough to alter drainage. The valley was not unstable. It was alive. Traditional foundations were immediately ruled out. Any rigid structure anchored directly into the soil would be pulled apart over time. The land's motion was too slow to resist, too persistent to ignore. Engineers realized they were not dealing with a single landslide or fault, but with continuous creep, a geological condition that never announces itself, but never stops either. The initial designs collapsed under that reality. Concrete slabs fractured in simulation. Piers bent as the soil migrated. Even flexible systems showed signs of cumulative stress. The valley did not break structures quickly. It wore them down patiently. The breakthrough came when the team stopped focusing on the ground and started focusing on space above it. Instead of building on the valley, they would build over it. The hotel would be lifted, suspended, separated from the soil's movement by a system designed to absorb slow change without transferring it upward. The structure began to resemble a bridge more than a building. Tall supports reached down to stable rock layers far beneath the drifting surface. Above them, the hotel floated, not rigidly fixed, but delicately balanced, able to adjust its position over time. But elevation introduced its own fears. Could guests trust a building that acknowledged movement instead of hiding it? Could comfort exist when the land below was known to be shifting, even if imperceptibly? And how long could such a system endure a valley that never intended to stop moving? As construction advanced, instruments recorded the truth daily. The ground continued its quiet journey. The supports compensated. The structure adjusted. And slowly, the team realized something unsettling. They were not building above a valley that moved occasionally. They were building above a valley that would never stop. The realization changed the tone of every decision. This was no longer about withstanding a phase of instability. The valley's motion was permanent, measured not in days or seasons, but in decades. Any structure here would face an unending test of patience. As the supports reached deeper rock, the contrast became unmistakable. The surface soil drifted steadily downhill, while the anchor points remained immovable. That difference created a new tension, not violent, but relentless. Over time, even small mismatches in movement could accumulate into serious stress. The first warning appeared quietly. Monitoring equipment showed microloads building along the upper joints where the suspended structure met its supports. Nothing alarming in isolation, but the trend was clear. The valley was slowly pulling the building out of alignment, millimeter by millimeter. If left unchecked, the forces would eventually concentrate enough to cause failure. Engineers proposed periodic realignment, mechanical corrections to reset the structure's position every few years. Designers resisted. Manual correction would interrupt operations, disturb guests, and treat the valley as a problem instead of a condition. The debate sharpened around a central question. Should the hotel be corrected, or should it correct itself? The breakthrough came from studying long-span bridges in seismic regions. These structures do not fight slow ground movement. They accommodate it continuously through sliding bearings and self-centering systems. Instead of accumulating stress, they release it incrementally. Applying that philosophy, the hotel's core system was redesigned. The upper structure was placed on multi-directional bearings that allow controlled lateral drift. Over time, the building could shift slightly without transferring force to its supports. The hotel would remain level internally, even as its position relative to the valley subtly changed. But this introduced a psychological challenge. Guests might never feel the movement, but they would know it existed. The idea of sleeping above a landscape that was literally sliding beneath them unsettled even some members of the team. Comfort, they realized, was as much emotional as physical. Interior spaces were redesigned with that in mind. Sightlines emphasized stability. Materials absorb vibration. Subtle visual cues reinforce balance and calm. The building would never pretend the valley was still, but it would ensure the experience felt grounded. As the systems came online, the data shifted. Stress flattened. Loads equalized. The hotel began to move with the valley instead of against it, drifting just enough to prevent strain. Yet one final challenge remained. Seasonal rains intensified the valley's motion, accelerating creep beyond average rates. The question now was not whether the hotel could adapt slowly, but whether it could respond when the land decided to move faster. And the valley, as always, was preparing to remind them who set the pace. The acceleration came after weeks of steady rain. The valley absorbed water like a sponge, its surface layers loosening, sliding more freely over the denser strata below. Instruments that usually recorded gradual change began ticking faster. What had moved over months now shifted in days. The hotel responded exactly as designed. At first, bearings released tension. The structure drifted subtly, maintaining internal balance, while the land below quickened its pace. From the outside, nothing appeared different. From the data, everything was changing. Then a new pattern emerged. Movement across the valley was no longer uniform. One section began creeping faster than the rest, creating uneven forces along the support network. The hotel was no longer floating above a single moving surface. It was suspended over a landscape, pulling in multiple directions. The conflict sharpened instantly. Engineers warned that if differential movement increased, the bearings could reach their adjustment limits. Designers worried about the psychological impact if guests ever sensed correction cycles activating. The valley was testing not just the structure, but the philosophy behind it. The emotional peak arrived during a night inspection. A low, almost imperceptible sound echoed to the building. Not a crack, not a failure, but a release. One of the self-centering systems had activated, shifting the structure a fraction of a degree to redistribute load. The movement was smooth, controlled, safe, but the idea that the hotel had moved itself unsettled the team deeply. For the first time, the building was not merely responding to the valley, it was deciding how to respond. Autonomy had entered the equation. Debate erupted. Some argued for tighter limits, more human oversight, slower correction thresholds. Others believed the system needed greater freedom to keep pace with the land's unpredictability. The valley did not pause for committee decisions. Data from the following days resolved the argument. Where the system was allowed to respond freely, stress dissipated. Where restrictions slowed correction, load spiked. Control created vulnerability. Adaptation created stability. The truth became unavoidable. The hotel could not be micromanaged. It had to be trusted. With that decision made, the final configuration was set. The building would continuously adjust itself within safe parameters, maintaining equilibrium without intervention. Guests would never notice shifts as events, only as an enduring sense of balance. Yet one final test remained. A seasonal surge, expected within days, would push the valley to its fastest recorded movement in decades. If the system could endure that, it could endure anything. The valley was gathering itself, and the hotel was about to learn whether living above a land that never stops moving requires more than design, whether it requires faith. The surge arrived quietly, without spectacle. No landslide, no roar, just the valley accelerating into a pace that instruments had not recorded in generations. The land moved as it always had, patiently, decisively, without concern for what rested above it. Inside the hotel, systems awakened in silence. Bearings released. Supports redistributed load. The structure shifted in smooth, measured increments, maintaining its internal stillness even as the earth below slid steadily onward. Guests slept through it. That was the true climax. While the valley crept at its fastest rate in decades, not a single person inside the hotel felt fear, imbalance, or disruption. The building adjusted itself continuously, like a vessel trimming its sails in changing wind. What could have been a moment of crisis passed as an uneventful night. When morning came, engineers reviewed the data in disbelief. The system had not only survived the surge, it had optimized itself through it. Stress had never concentrated. Limits had not been reached. The hotel had learned the valley's rhythm more deeply than any model could predict. Word spread quickly. The hotel gained a reputation not as a marvel of risk, but as a study in trust. Visitors spoke a profound sense of calm, of resting above a landscape in motion without feeling threatened by it. Some described it as being carried rather than supported. The valley continued to move. It always would. But the hotel no longer treated that movement as a problem. It treated it as context. And that is a legacy of living above a valley that still moves, a reminder that stability does not require immobility. That safety can come from adaptation, not control. And that sometimes the most resilient structures are the ones that accept the world's slow, relentless change without trying to stop it. Sometimes the smallest shift in perspective becomes the beginning of a new future. Living